Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video explains a simple method for selecting the best multiple regression model. Let's get started. So, the way in which we typically select which multiple regression model is going to be the best is going to reside on three factors. The reason why we're having to select the best is because when you're making multiple regression models, you have multiple variables to consider. And oftentimes, let's say you've got 4 different variables to consider. So you'll make models for each pair of 2 variables that you have. And then you'll make models for each set of 3 variables you could have. And then a final model for all 4 variables. How do we know which of these models is the best for making predictions? Well, there's a simple method that we use. The first thing we look for is we want to look for a really good value of adjusted R-squared, because this will account for the explained variation in our models. Many use simply the R-squared value to adjust model fit, but as we learned in the previous mini lecture, R-squared will not be the same for comparing models with different sample sizes, or it will not be the same for comparing models with different numbers of variables. In fact, the value of R-squared will usually increase as you put in more variables and increase your sample size. So in order to have a level playing field, you really want to be looking at adjusted R-squared, because this provides a better accounting for the explained variation, since it considers the number of variables and sample sizes across your models. The second value we want to look at is the p-value, because this will measure the overall significance of our model. Generally, the smaller the p-value you have, the more significant the combination of variables in your model. So, whereas a higher adjusted R-squared value is appropriate, we want to get that as close to 1 as we can. Here with the p-value, we want to look for a value that's as close to 0 as we can get it. So when you're looking for a good p-value, think golf. Never use models with high p-values. I don't care what, how good the rest of the model is. If it's got a high p-value, that says that the model does not have overall significance and you should not use it. And finally, you want to use what's called sound judgment. Those who actually spend a lot of time making models day in and day out, and I used to do this for a while as part of my day job, it comes a point where you have to use sound judgment. Sometimes the best model that you're going to select is not the one with the best numbers to it. So you could have a really great adjusted R-squared value, you could have a really great p-value, but if the predictions that the model makes are just not realistic, then it's just not a good model and you don't want to be using it. You want to select a different model that has maybe not as good adjusted R-squared value or not as good a p-value, but actually makes better predictions. So you don't necessarily want to use the model that's got the best numbers to it. You want to make sure that you've got a model that makes good predictions. And as a general rule of thumb, models that use fewer variables are usually better. So think simple. Okay, simple is usually what you want to strive for here. Of course, the model has to make sense from both a creator and a user perspective. So it makes sense to the creator if it's useful for making predictions. It makes sense for the user if it's used in such a way so that the user doesn't have to convert values in order to use the model. The user can just plug a number in and out comes the prediction that's desired. Let's look at our earlier data set that we had for shoe print length and height. And let's make models to include 3 different variables in addition to shoe print length. So we've got age, we've got foot length, and we've got shoe size. So with those variables in place, we can make multiple regression models for different combinations of these variables. And you see that in the table here. Listed also with each of the models is the corresponding adjusted R-squared value and p-value from those models. So now that we've got this tabulated, we can compare these models with one another to figure out which one is going to be the best one, the one that we want to select. Well, right off the bat, we can eliminate the model for age because it has a really low adjusted R-squared value. Okay, the p-value is also, I mean, it's a low p-value, but it's higher than the others that you see there in the table. I mean, everything else has got a p-value of 0. So we're just going to go ahead and eliminate this first model from our consideration. Of the models that remain, let's look at these last two here that have the most variables in them. Okay, they have higher adjusted R-squared values, but they also have more predictor variables. So if you look at, say, like the model for foot length, there's only one variable there, and it has an adjusted R-squared value of 0.7. But if you add another variable or two, you're only increasing that adjusted R-squared value up to like 0.74, 0.75. That's not a very significant climb for adding more complexity to your model. So again, simpler is often better, and we want to strive for simplicity when choosing the model. So we don't get that much more gain from the adjusted R-squared value because we added the complexity to the model. So we're not going to choose those more complex models. We're going to eliminate them from our consideration. Now we've got two models left to consider. How do we choose between the two of them? Well, it's pretty simple. The p-values are the same, but the adjusted R-squared value for the one is higher than the other. So we don't have a difference in the number of variables between those two models. So we're just going to take the one with the higher adjusted R-squared value, and that's going to be the model that we end up selecting. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.